Hello dear students, in this video I'll continue with Unit 4 Probability Distributions. I'll solve the questions on Poisson distribution from section 4.8 of Check Your Progress. So the 12th company, a customer care company receives an average of 4.5 calls every 5 minutes. If each customer executive handle one of these calls over the 5-minute period, but if an executive is not available to take the call, then the call is put on hold. Assuming that the calls received by the customer care company follows a Poisson distribution, what is the minimum number of customer executives are needed on duty so that calls received are placed on hold for at most 10% of the time? So here it is said a customer care company receives an average of 4.5 calls every 5 minutes. So every 5 minutes average of these many calls are received, and it is given each customer executive can handle one of these calls over this 5-minute period. But if an executive is not available, the call is put on hold. And now we need to find the minimum number of customer executives who are required on duty so that the calls received it is on hold for at most 10% of the time. Here we have to assume that the calls received follows a Poisson distribution. So let x denote the number of calls in 5 minutes. Here they have given it receives an average of 4.5 calls every 5 minutes. So lambda is directly given here. So given lambda is 4.5. So x follows a Poisson distribution with this parameter lambda 4.5. So we can write the probability distribution of x. It is given by probability of x is equal to k equal to e raised to minus lambda raised to k upon k factorial. Here lambda is 4.5. So it is e raised to minus 4.5 raised to k upon k factorial. So this is the probability distribution function for k. Now we need to find the minimum number of customer executives required on duty so that the calls received are placed on hold for at most 10% of time. So we have to find probability of x greater than k is less than or equal to 10%. This 10% is nothing but 0.1. So we need to find the minimum number of k so that probability of x greater than k is less than 0.1. So probability of x greater than k is nothing but 1 minus probability of x less than or equal to k. It is less than or equal to 0.1, or 1 minus 0.1 less than or equal to probability of x less than or equal to k. So from this we get 0.9 less than or equal to probability of or probability of x less than or equal to k should be greater than or equal to 0.9. So we need to find that value of k such that probability of x less than or equal to k is greater than or equal to 0.9. Now probability of x is equal to 0 is e raised to minus 4.5 raised to 0 upon 0 factorial. E raised to minus 4.5 it is given as 0.011. It is 0.011. So we have to substitute one by one for different values of k, and we have to check where we get the value of k such that probability of x less than or equal to k is more than or equal to 0.9. So let us draw a table like this. So here let us have k Here let us have probability of x is equal to k, and here let us have probability of x less than or equal to k. Probability of x equal to k is e raised to minus lambda, lambda raised to k by k factorial. So we already found probability of x is equal to 0. It is 0.011. Now let us find this for probability of k equal to 1. So probability of x is equal to 1. It is e raised to minus 4.5, 4.5 raised to 1 by 1 factorial. So it is 0.1011 into 4.5. This is equal to 0.0495. So here we have probability of x less than or equal to 1. It is probability of x is equal to 0, 1. Probability of x equal to 0 is 0.011 plus probability of x equal to 1 is 0.0495. When we add these two, it is 0.0605. Now this 0.0605, it is not more than 0.9. We need to find probability of x less than or equal to k greater than or equal to 0.9. We have to find that value of k. This is not more than 0.9. Now let us try 2. So probability of x is equal to 2 will be e raised to minus 4.5 into 4.5 the whole square upon 2 factorial. So this e raised to minus 4.5 into 4.5 by 1 factorial is 0.0495. So this will be 0.0495 into 4.5 by 2. I am doing this to reduce the calculation because we already got e raised to minus 4.5 into 4.5. It is this value. So that value I am substituting. Remaining we are left out with 4.5 by 2. So that I am putting it here. Now this when we simplify, we get it as 0.1114. Now let us find probability of x less than or equal to 2. So it is probability of x is equal to 0, 1 and 2. We already got probability of x less than or equal to 1. It is 0.0605 plus probability of x is equal to 2 is, this is probability of x less than or equal to 1, it is this value, then plus probability of x is equal to 2, it is 0.1114. Now when we add these two, it is 0.1719. Again it is not more than 0.9. Still we have to proceed. Now for k equal to 3, probability of x is equal to 3 is e raised to minus 4.5 into 4.5 cube upon 3 factorial. Already for this whole thing, e raised to minus 4.5, 4.5 square by 2 factorial, we got 0.1114. So this will be 0.1114 into 4.5 divided by 3. So this when we simplify, we get it as 0.167. Now here probability of x less than or equal to 3, it will be probability of x is equal to 0, 1, 2 and 3. Probability of 0, 1, 2, it is 0.1719 plus 0.167. Now this when we add, we get it as 0.3389. Still it is not more than 0.9. Still we have to proceed. Now let us try for k equal to 4. So probability of x is equal to 4 is e raised to minus 4.5, 4.5 raised to 4 by 4 factorial. Now e raised to minus 4.5, 4.5 whole cube by 3 factorial is 0.167. So this will be 0.167 into 4.5 divided by 4. Now this comes out to be approximately 0.1879. Now let us find probability of x less than or equal to 4. So it is nothing but probability of x is equal to 0, 1, 2, 3 and 4. We already got probability of x is equal to 0, 1, 2 and 3. It is 0.3389. So probability of x less than or equal to 4 will be 0.3389 plus probability of x is equal to 4. That is this value. It is 0.1879. When we add these two, we get it as 0.5268. Again, it is not more than 0.9. Still, we have not found k. Now, let us try for k equal to 5. Probability of x is equal to 5. It is e raised to minus 4.5, 4.5 raised to 5 by 5 factorial. The value for this, we have got 0.1879. So, it will be 0.1879 into 4.5 by 5. So, this comes out to be 0.1691. Now, probability of x less than or equal to 5, it will be this probability plus this value. It will be probability of x less than or equal to 4 plus this value. So, it is 0.5268 plus 0.1691. So, it is 0.6959. Still, it is not more than 0.9. Now, let us try 6. Probability of x is equal to 6 is e raised to minus 4.5, 4.5 raised to 6 by 6 factorial. So, for this e raised to minus 4.5, 4.5 raised to 5 by 5 factorial, it is 0.1691. So, this will be 0.1691 into 4.5 divided by 6. So, this when we simplify, we get it as 0.1268. And now let us find probability of x less than or equal to 6. Now this probability of x less than or equal to 6 will be probability of x is equal to 0, 1, 2, 3, 4, 5 and 6. Already we got for x is equal to 0, 1, 2, 3, 4 and 5, it is 0.6959 plus we have to add probability of x equal to 6. 0.1268. Now let us check whether at least this is more than 9. This when we add, we get 0.8227. Again, it is not more than 0.9. Now let us try for k equal to 7. Probability of x is equal to 7. It is e raised to minus 4.5, 4.5 raised to 7 upon 7 factorial. Now this will be probability of x is equal to 6 into 4.5 by 7, because for this we got the value, for this expression we got the value as 0.1268 into 4.5 divided by 7. Now this when we simplify, we get it as 0.0815. Now let us find probability of x less than or equal to 7. Probability of x less than or equal to 7 will be probability of x less than or equal to 6 plus probability of x equal to 7. So it is 0.8227 plus 0.0815. Now when we add these two, we get it as 0.9045. So finally we got the value of k, for which probability of x less than or equal to k is more than 0.9. So when k equal to 7, probability of x less than or equal to 7 greater than or equal to 0.9. So the minimum number of customer executives who are needed on duty so that the calls received are placed on hold for at most 10% of the time is 7. Therefore, minimum of 7 customer executives are needed so that the calls received are placed on hold for at most 10% of time. So this is the answer. 7 is the answer. If you do slowly step by step, then the calculations are not very difficult. They are quite easy only. Next question. A statistician records the number of trucks approaching a particular intersection to analyze the flow of traffic. He observes that on an average, 1.6 trucks approach the intersection every minute. Assuming that the number of trucks approaching the intersection follow a Poisson distribution model, what is the probability that 3 or more trucks will approach the intersection within a minute? So here everything is given directly. Average of 1.6 trucks approach intersection every minute, and then we are asked to assume the number of trucks approaching follows a Poisson distribution model. We need to find the probability that 3 or more trucks will approach the intersection in 1 minute. So let x denote the number of trucks approaching the intersection in a minute. Then lambda is given as 1.6. X follows Poisson distribution with parameter lambda 1.6. So the probability distribution function of x is given by probability of x is equal to k equal to e raised to minus lambda raised to k by k factorial. Here lambda is 1.6, so it is e raised to minus 1.6. 1.6 raised to k upon k factorial. Now we need to find the probability that 3 or more trucks will approach the intersection within a minute. That is, we need to find probability of x greater than or equal to 3. Now this probability of x greater than or equal to 3, it is nothing but 1 minus probability of x less than 3, or it is 1 minus probability of x is equal to 0, 1 and 2. So it is 1 minus probability of x equal to 0 plus probability of x equal to 1 plus probability of x is equal to 2. So it will be 1 minus probability of e raised to minus 1.6, 1.6 raised to 0 by 0 factorial plus e raised to minus 1.6, 1.6 raised to 1 by 1 factorial plus e raised to minus 1.6, 1.6 the whole square by 2 factorial. So this is 1 minus e raised to minus 1.6 is common, which can be taken outside, into 1 plus 1.6 plus, here we have 1.6 the whole square by 2, 2.56 divided by 2. So this is 1.28. So it is 1 minus e raised to minus 1.6 is 0.202. 0.202. Now this, when we add, we get it as 3.88. So it is 1 minus 0.784, or it is equal to 0.216. Therefore, probability of the 3 or more trucks will approach in a minute equal to 0.216. So this is the required probability. Now moving on to the next question. A computer disk manufacturer tests disk quality on random basis before approving it. The approval is based on the number of errors in a test area on each disk and follows Poisson distribution with lambda equal to 0.2. What is the percentage of test areas having 2 or smaller number of errors? So here everything is given directly. It is given the number of errors in a test area follows Poisson distribution and lambda equal to 0.2. We need to find the percentage of test area having 2 or smaller errors. So first let us find probability of x less than or equal to 2. Then if we multiply by 100, we'll get the percentage. So let us take, let x denote the number of errors in a test area. Lambda is given as 0.2. So probability of x is equal to k. It is e raised to minus lambda, lambda raised to k upon k factorial. We need to find the percentage of test areas having 2 or smaller number of errors. So for that, let us find probability of the test areas having 2 or smaller number of errors, which is probability of x less than or equal to 2. So probability of x less than or equal to 2 is probability of x is equal to 0, 1 and 2. So it is e raised to minus 0.2, 0.2 raised to 0 by 0 factorial plus e raised to minus 0.2, 0.2 raised to 1 by 1 factorial plus e raised to minus 0.2, 0.2 the whole square by 2 factorial. E raised to minus 0.2 is common, let us take it outside, into 1 plus 0.2 plus 0.04 divided by 2. E raised to probability of x less than or equal to 2 is e raised to minus 0.2 they have given as 0.8187. Now this when we add, we get it as 1.22. This when we multiply, we get it as 0.9988. This 0.9988 is nothing but 99.88%. Therefore, 99.88% of the test areas have 2 or smaller number of errors. So this is the answer. Next question, in a Poisson distribution, if mean is to, what is variance? Now we know in a Poisson distribution, the mean equal to the variance equal to lambda. So in a Poisson distribution, mean equal to variance equal to lambda equal to 2 implies variance equal to 2. Next question, it is given that 3% defective electric bulb are manufactured by a company. Using Poisson distribution, find the probability of 100 bulbs will contain no defective bulbs. So here they have given probability of defective bulbs and we have to use Poisson distribution to find the probability of 100 bulbs will contain no defective bulbs. So probability of defective bulb, that is P, it is given as 0.03. Now let us denote the number of defective bulbs in 100 bulbs. So N is 100 here. Lambda is equal to NP. So it is 100 into 0.03, which is 3. So X follows Poisson distribution with 3 as the parameter. Now we need to find probability of 100 bulbs will contain no defective bulbs, meaning that probability of X is equal to 0. There will be no defective bulbs in 100 bulbs. So we need to find probability of X is equal to 0. So for that, first let us write what is probability of X is equal to K. It is e raised to minus lambda, lambda raised to K by K factorial. Now probability of X is equal to 0. It is e raised to minus 3, 3 raised to 0 by 0 factorial. E raised to minus 3, it is given as 0.05. So it is 0.05. So probability of 100 bulbs will contain no defective bulbs is 0.05. Therefore, probability of 100 bulbs will contain no defective bulbs equal to 0.05. Now moving on to the next question. The mortality rate for a certain disease is 0.007. Using Poisson distribution, calculate the probability for 2 deaths in a group of 400 people. So here it is given the mortality rate, that is the rate at which people will die, that is called mortality rate. For some disease it is 0.007. We have to use Poisson distribution to calculate the probability of 2 deaths in a group of 400 people. So let X denote the number of deaths in 400 people. Here they have given the mortality rate is 0.007. So lambda is 0.007. This 0.007 is nothing but it is 7 in 1000. So in every 1000 people, 7 people die out of this disease. But they have asked probability for 2 deaths in a group of 400 people. So we have taken X as the number of deaths in 400 people. As a result, the width or the number of people n is 400. So we have expectation of X as lambda into W. It is 0.007 into 400, which is 2.8. So here X follows Poisson distribution with parameter 2.8. Now let us write the probability distribution for X. Probability of X is equal to K is given by e raised to minus 2.8, 2.8 raised to K upon K factorial. So usually in the exam, finding the probability distribution of X up to this step, it carries 1 mark, and then whichever probability we have to find, that step carries 2 marks. If there are 2 subdivisions, then each subdivision will carry 2 marks. So up to this step carries 1 mark. Now we have to find probability of X is equal to 2. That is probability of 2 deaths in a group of 400 people. So it is e raised to minus 2.8, 2.8 the whole square upon 2 factorial. E raised to minus 2.8, it is given as 0.06. So probability of X is equal to 2 is 0.06 into 2.8 the whole square is 7.84 divided by 2. So this when we simplify, it is 0.235. Therefore, probability of 2 deaths in 400 people, it is 0.235. This is the required probability. So up to this step will carry 1 mark, and finding the probability will carry 2 marks. Next question, in Poisson distribution, an ice cream parlor receives a customer at an average rate of 4 per minute. If the number of customers received by the parlor follows a Poisson distribution, what is the approximate probability that 16 customers will be coming to the parlor in a particular 4-minute period on a given day? So here the average rate is given, it is 4 per minute. The average rate of customers at an ice cream parlor is 4 per minute, and the number of customers received by the parlor, it follows Poisson distribution. We need to find the approximate probability of 16 customers who will be coming in a particular 4-minute period. So here whichever probability is asked, that let us take it as X. So let us take X denote the number of customers in a 4-minute period. But lambda is given as 4 per minute. So lambda is 4 per minute. But we have taken X as number of customers in a 4-minute period. So the width is 4. As a result, expectation of X will be lambda into W, it is 4 into 4, 16 per 4 minute. Now let us write the probability distribution function of X. Probability of X is equal to K is e raised to minus 16 raised to K upon K factorial. we have to find the approximate probability that 16 customers will be coming in a particular 4-minute period. So we have to find probability of x is equal to 16. It is e raised to minus 16, 16 raised to 16 by 16 factorial. Here the calculation was very huge and it was tedious. Even e raised to 16 is a very small quantity. So I have used the calculator. The answer was 0.09922. So let us hope such questions we do not get in the exam. So these are the questions on Poisson distribution from the check your progress section of 4.8. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. Thank you for watching.